All right, let's go ahead and look at this. So right off the bat, okay, I have student A and student B, and the train itself is accelerating. So one important thing to note whenever you're doing this problem is that what student B is doing to student A is what? What are they doing? They're throwing a ball, right? So the ball gets thrown in the air from student B to student A. So as the ball is traveling to A, it's not in contact with the train. Therefore, this acceleration is not applying to the ball as it's in the air. Okay? It's being applied to the train. So, in order to do this question, you have to set up the equation, the velocity of the ball in reference to the train. And the way that I set this up is that I know that there are two objects in this situation. So I'm going to say the velocity of the ball to the train, and I say ball to the train because they actually give you a value for that. It's going to be equal to the velocity of the ball to the what? To the ground, right? So the ball to the ground or ball to the earth minus the velocity of the train relative to the earth. So I'm going to draw my earth here. This is earth, okay? Her name is Earth. So when we are looking at this problem, it says that student A throws a ball to the left towards student B. Oh, I actually drew it wrong. Okay. Student A, there we go. To student B with a horizontal velocity of 4 relative to the train. So I'm going to consider my positive direction to be this way because I can just choose it. So that means I'm going to have a velocity of the ball relative to the train to be 4. And then I say at the instant that the ball leaves student A's hand, the speed of the train relative to the ground is 10 meters per second to the right. So if the speed of the train relative to the ground is 10 to the right, is it positive or negative 10? Negative 10, right? So negative 10. So then, therefore, I want to find the horizontal speed of the ball relative to the ground. So go ahead and solve for that. And you should get 6, right? So 4 minus 10, or 4 minus 10 is negative 6. Okay, but what is the question asking for? Speed or velocity? Speed. So it doesn't even matter if it's a negative or positive. There you go. B. Okay. All right, go ahead and select B on y'all's AP thingy. Okay, let's go on to the next problem. So question 2. I'll give y'all a second to read through it. And it's actually going to be a 2-step problem. And I'm also recording this session for my people that can't make it. So for my people that can't make it, here is the explanation for answer B for question number 1. Okay, so number 2 says water in a river flows uniformly to the east with a speed of 5 meters per second relative to the shore. A boat is traveling to the west at 10 meters per second relative to the water. So in this case, what is considered earth or our ground? The shore, right? Because the shore is going to be the edge. So when I draw this out, this person's on the shore. The water flows at 5 meters per second relative to the shore. So I can say the velocity of the water to earth is going to be 5. And I'm going to keep east as positive. A boat is traveling west at 10 meters per second relative to the water. So what I can set up is my velocity equation of the boat, because they give us a velocity of the boat relative to the water. Therefore, that's going to be equal to the velocity of the boat relative to what? The shore or the earth, minus the velocity of the water relative to E for earth. Okay? So from here, I can just plug things in because I know that I'm given velocity of the water, which is 5. And I'm not going to add negative or positive because it's east. And I am also given 10 meters per second west. So west is going to be considered negative. So negative 10 meters per second. And from here, I can actually solve for the velocity of the boat relative to the earth or the shore. What is that going to be? It's going to be negative 5, yeah. So it's going to be negative 5 or 5 meters per second to the west. Okay, so looking at the question, it says, what is the passenger's velocity? I skipped over a sentence. A passenger on the boat is walking at 5 meters per second to the east. So they throw in another variable, that's the passenger. But what I can set up is my equation where velocity of the passenger to the boat is equal to the velocity of, I'm just going to do velocity of P minus velocity of B. Which of the following statements about the passenger's velocity is correct? And just by skimming the answer choices, it looks like it wants me to solve for the speed that's relative to the shore or the earth, right? So it looks like it wants me to solve for this one. So that means I need to have everything else to solve for it. I already have velocity of the boat, negative 5. Negative 5 can be plugged in here. And didn't my question give me velocity of passenger to the boat? Yeah, it did. So let's go ahead and plug that in. So we have negative 5 minus velocity of the passenger is equal to the velocity of the boat, which is going to be, the passenger on the boat is walking 5 meters per second to the east. Is that positive or negative 5? Positive. Go ahead and solve for V of P. So what is V of P going to be? 0. So which one is correct? Either C or D, right? So you said it was C. It is C. And let's look at the difference between the two. The passenger is stationary relative to the shore because the boat is moving at 5 meters per second relative to the shore, and then the passenger is moving at 5 meters per second relative to the boat in the opposite direction. That is correct. We know that this is not correct because it says that the boat is moving 5 meters per second, which is incorrect because we've got 5 as our answer. Okay, let's go ahead and move on. Okay, I want to choose a question. Let's go to question 12. We got some graphs in. And then we're going to do question 19. 12, then 19. All right, so looking at question 12, question 12 is going to have a position and time squared graph. So looking at this, we're not used to having a square in our axis. However, what should your mind immediately go to if you see like a square or a square root? Linearization, exactly. So my mind immediately goes to linearization. For one, that's a linear graph. So that means this has to be based off an equation that probably has position and time squared. This is unit 1, so my equations that I can use is going to be my UAM equations. And I know UAM because we have position and time. So the equation that you would use would be x final is equal to x initial plus velocity times time plus 1/2 acceleration times squared. The reason why I chose that equation was because I see position and I also see time squared. If you look at your other equations, there's no time squared. So I want to go to this. And somehow I want to linearize it. And I'm going to say that my position is going to be just change in x. So I'm going to move x initial onto the other side. And I have velocity initial, which is going to be right over here. So at time 0, the car starts at x equals 0. The graph shows the position of the car as a function of time. Which one of the statements correctly describes the motion of the car? So let me see if it... So it doesn't say that the car is starting from rest. However, trying to find a way to explain why I'm going to get rid of this. The reason why you would get rid of this is because it starts from rest, but it doesn't say anything here from it. But let's assume in this case that the car is starting from rest. So we have 1/2 acceleration times squared, and that is how I'm going to linearize my graph. Okay. So, oh wait. Let me backtrack on that. That I actually have a better explanation. Okay. So instead of assuming that, okay, what I can say is that my y-intercept can be velocity times time, because this can be y, or no, this is my my b, this is going to be my mx, and then this is going to be my y. My y equals mx plus b equation, just like that one F for Q that we used. So on my y-axis, that's position, my x-axis, that is time squared, and then my b is going to be velocity times time. But luckily, we're not being asked about b. So that tells me that my slope for this is going to be 1/2 acceleration. And then I know that when I read through the problems, letter A, the car moves with a constant speed, momentarily stops, and then moves again with the same speed. The car is speeding up at a constant rate, then continues to speed up, but at a slower rate. C, the car moves with a constant speed, then it quickly slows to a different constant speed. Or D, the car is speeding up at a constant rate, then slows down at a constant rate. So which one of these can we get rid of? A. Why do you say A?
Velocity is never 0, so nothing to stop it.
Yes, and I know that because looking at this equation, my slope has acceleration in it. So there has to be some acceleration if there's slope. So therefore, I get rid of A. What else can I get rid of? D as well. A. And then also C, because it also says constant speed. So then your answer is B. So the car is speeding up at a constant rate, then it continues to speed up at a constant rate. And in both situations, your acceleration is going to be positive. Okay? All right. That is all the time we have for today. I'm going to do my best to incorporate more questions for y'all. But thank you for coming to our first AP review session. Don't forget that you have signed in. All right, thank you.